Let alpha and beta be the roots of x square minus x minus 1 equal to 0. If pk is equal to alpha par k plus beta par k, where k is greater than or equal to 1, which of the statements is not true? So we can see a couple of statements. P1 plus P2 plus P3 plus P4 plus P5 is 26, P5 is 11, P3 is equal to P5 minus P4, P5 is equal to P2 into P3. So all we understand is we need to get the value of the terms involving P1 to P5. So getting the roots of this equation is not a great idea because the roots are not going to look good. The roots are going to be 1 plus or minus root 5 by 2. So let's go with sum of the roots and product of the roots as we always do. Sum of the roots is equal to minus b by a. Product of the roots is equal to c by a. Let's try getting the value of p1. P1 is nothing but alpha plus beta, which is equal to 1. And P2 is going to be alpha square plus beta square, which is alpha plus beta the whole square minus 2 alpha beta, which is going to be 1 plus 2, which is equal to 3. Now instead of getting P3, P4, P5, etc., let's try to generalize a relation. So let me try finding out a relation between Pk plus 1 minus Pk. This is alpha power k plus 1 plus beta power k plus 1 minus of alpha power k plus beta power k. So I can simply write the second term. The first term is of degree k plus 1. This is of degree k plus 1. This is of degree k. This is of degree k. So we have to make this also as degree k plus 1 so that some terms will get cancelled. So I will simply put a 1 here and replace that 1 as a alpha plus beta. So can I write this as alpha power k plus 1 plus beta power k plus 1 minus that 1 I am going to replace it as alpha plus beta into alpha power k plus beta power k. Let's open the bracket. So first term is alpha power k plus 1 plus beta power k plus 1. Next term is going to be, when I multiply these two, I'll get a minus alpha power k plus 1. If I multiply these two, minus beta power k plus 1. And the other terms are minus alpha beta power k minus beta alpha power k. So I can cancel these terms. So I am left aside with this. So you can pull out a minus alpha beta common. Within bracket you have alpha power k minus 1 plus beta power k minus 1. You know that alpha power k minus 1 plus beta power k minus 1 is pk minus 1. We know alpha beta is minus 1. So if you replace alpha beta as a minus 1, minus of minus 1 will be 1. So I get this to be equal to pk minus 1. This kind of results will help in understanding, even if they give you higher expressions, P10, P9, P8, these type of relations will be definitely useful. So what is the relation we have arrived at? Pk plus 1 is equal to Pk plus Pk minus 1. So we have a relation Pk plus 1 is equal to Pk plus Pk minus 1. We already had the values of P1 and P2. P1 is 1, P2 is equal to 3. P1 is equal to 1 and P2 is equal to 3. We have the values of these two terms. So if you want P3, you go back to this relation and put K is equal to 2 here. So what do we get? P3 is equal to P2 plus P1, which is 3 plus 1 is equal to 4. If you want P4, put K is equal to 3 here. So we get P4 is equal to P3 plus P2, which is equal to 4 plus 3 is equal to 7. If you want P5, put K is equal to 4 here. So we get P5 is equal to P4 plus P3, which is going to be 7 plus 4, which is equal to 11. So we have the values of all the terms. So first one, if I remember, P1 plus P2 plus P3 plus P4 plus P5 was the first one, which is 11 plus 7 is 18, 22, 25, 26. Let's see what the first option is. The first option is sum of P1 plus P2 etc. is 26, which is true, but the question is which is not true. So option 1 is true. Then option 2 says P5. P5 is equal to 11. P5 is equal to 11. Option 2 is also true. Option C is P5 minus P4 is P3. P5 minus P4 is equal to P3. 11 minus 7 is equal to 4. So option C is also true. Option D is P2 into P3 is P5. P2 is 3. P2 into P3. Is it right? P2 into P3 is P5. So P2 into P3, P2 into P3 is 3 into 4, 12, which is not P5. That means out of the given options, which of the following is not true? Option D is not true. So the answer to this question is option D. Getting a general relation instead of getting the individual values of P3, P4, P5, etc. Solving it like this would make it easier. Even if there is an involvement of P10, P11, using the relation that we have established, we can get the values in an easier manner.